I want to go over another key distribution system. So this is, I guess, based on Eckert, Chow, and Low. So suppose Alice and Bob share n perfect EPR pairs. Well, the EPR pairs are a quantum state that's entangled, and they measure them. Get random correlated bits. So if they measure them in the right, left base, up, the horizontal vertical basis, whenever Alice's bit is vertical, Bob's might be horizontal, and vice versa. So they get perfect random correlated bits, which is a quantum key. It's a secret key, and we know that nobody else can get this because nobody can predict what bit. No, nobody can predict the outcome of a quantum measurement. So here's the new protocol. Alice and Bob use CSS code, or Alice uses a CSS code to encode half of their Alice here. Let's do this. Alice prepares n EPR pairs, intersperses m test qubits, and encodes one of each pair in CSS code. And now she intersperses m test qubits with a CSS code in a random state. And she sends them to Bob. Sends, well, half of the EPR pairs, rather, half of each EPR pair. Well, she sends the encoded EPR pairs and the test qubits to Bob. So Alice, I should really draw a picture of this. And Bob stores everything in memory. In quantum memory. Alice sends Bob, well, the positions of the test qubits. And I guess values of the test qubits. Bob measures error rate. And decodes. And now Bob, when he measures the error rate, he knows whether the quantum error correcting code is strong enough to overcome the error rate. So when he decodes it, he knows if the quantum error correcting code is strong enough to overcome this error rate. Bob knows that he and Alice share perfect EPR pairs, so he can get the values of the qubits. So Alice has EPR pairs. And test qubits. And now she encodes these, half of these, in an error-correcting code. And she intersperses the test qubits and sends these to Bob. And then Bob gets them. Alice tells Bob which were the test qubits. Bob measures them and estimates the error rate, and then he decodes these. And now Alice and Bob share a perfect EPR pair.